Good afternoon. My name is Brian Gromkowski. I'm one of the Assistant Directors of Graduate Admissions here at William Paterson University. I want to thank all of you for taking time out of your schedule to join us today for our webinar about our MS in Materials Chemistry. I am joined today by Dr. Bhanu Chauhan, as well as several other faculty from within our Department of Chemistry. They're going to be speaking to you in just a couple minutes at length about the program, and I just wanted to go over a few items real quick before we get started. First, I want to make sure you know that looking a little bit further ahead, on Sunday, February 10th, we're going to be having our next graduate admissions open house. And I mention that because if you are interested in what you hear today about our program and you'd like the opportunity to not only see our campus, but also get the chance to talk to faculty from within the department about your interest in the program and about applying for the program, that's certainly a great opportunity to do so. Our hope is that a webinar like this is a good way to get a lot of information in a relatively short amount of time. But certainly there's no substitute for being here physically on campus. So we'd love to have you if that works with your schedule. Again, that's Sunday, February 10th. It's going to be from 1 to 3 p.m. Also want to make sure you know we realize that there are a lot of reasons families are busy right now this time of year. You may be only able to stay for part of the webinar. Some may join us a few minutes late. So we just want to make sure you know we are going to be recording this presentation in its entirety, and we are going to be making our YouTube link available to you after the recording is completed, probably by the end of this week. So if you did need to catch up on any information, if you wanted to refer back to any of the slides that you see here or any of the information that was helpful for you, you'll have that opportunity. So we encourage you to be hands-free, no pens, no notes, or anything else while you take in the presentation. Lastly, just want to make sure you know if you do have any questions as we go through the presentation, you can type them in the chat box there on the GoToWebinar screen. If it's something that we can field really quickly for you, we'll do so and answer it. If it's something that's more appropriate to save for one of the members of the department at the end of the presentation, we'll have the opportunity to do that as well if needed. But that's certainly more than enough for me. I know you're here to hear from our different faculty, to get to meet them, and to learn more about the program. So without further ado, Bhanu, take it away.
Thank you, Brian. Good afternoon. This is Professor Bhanu Chauhan. I have the privilege and honor of chairing this vibrant, outstanding, and student-centered chemistry department of William Paterson University. Today, I and my colleagues are going to talk about our MS in Materials Chemistry program, which is new offering of our department. First of all, I want to tell you why we chose to create this new program and what is so unique about it. The materials chemistry is unique in the sense that it combines the visual beauty of art with creative skill and imaginative investigation of materials in the ways in which they interact, combine, and change. This is very unique and groundbreaking chemistry program in tri-state area, and our mission is to provide chemists, chemistry educators, and material scientists with a cutting-edge curriculum focused on design and synthesis of new generation of materials. We offer research-based curriculum, which helps the student obtain the skills to succeed in cutting-edge scientific industries focused on the development and applications of advanced materials. Our goal is to prepare chemists and materials researchers seeking to advance their careers in industrial, government, and military laboratories. Additionally, students who complete our program will be prepared for competitive doctoral programs in chemistry and material science and engineering. This webinar is divided into following 5 subsets. I will present to you the program information, curriculum details. Dr. Yalan Xing will give a flavor of our faculty expertise. Dr. Foley will present to you our facilities and instrumentation along with our your career choices after the program. And finally, my colleague, Dr. Parminder Kaur, will tell you more about our success stories. So what is so unique about materials chemistry program and why one should do materials chemistry, particularly the graduate program in material chemistry? The unique feature of this program is our focus is on future. What I mean by that is that we want to provide chemistry training for future economy. So we want to train the chemists who will be prepared for dealing with the problems in futuristic terms. So first and foremost, our aim is to equip students with the cutting-edge knowledge based in theoretical, practical, and experimental aspect of chemistry of materials. We focus our training on creative research and problem-solving skills. Thirdly, the program is devised to prepare future leaders in the field of material chemistry. We want to empower students who are able to innovate new synthetic, fabrication, characterization, and theoretical methods and create new opportunities in their subfield of choice. Now let me talk a little bit about the curricular details and the course sequences. Our program is divided is of 32 to 33 credits depending on what elective courses you choose, and there is basically 3 subdivisions in the program. One is required core courses, the other one is required research courses, and the third one is elective courses where you are required one is required to take 2 courses. So our core courses are in the field of general inorganic and materials chemistry, organic materials chemistry, analysis of materials, theoretical and physical methods in chemistry. Our required research courses are: the first course prepares you, the graduate seminar course prepares you in research methods and literature survey. Then one does laboratory research method 1, 2, and 3 in consecutive semesters, which in other words that this laboratory research prepares one with hands-on experience to be able to work as soon as you finish the program. The third is elective courses. Based on the student's choice, they can choose nanochemistry or technology as a course, biomaterials as polymer, or application of materials. And we are developing some new offerings in near future, which will be in the diverse field of materials chemistry. In other words, that one is required to do 32 to 33 credits, and one can finish the program if one is doing full-time in 2 years or 1.5 years, depending on what kind of coursework they have done before. There is another unique feature which I want to bring about, which is that our the third research course, or one of the laboratory research courses, one can substitute it with the industrial internship. If one is working in industry, they can use that particular work experience as industrial internship. And more details are provided when the students meet with the counselor. This is one of the kind of suggested sequence of courses just to prove that one can finish it in 2 years. In first semester, for example, the students who are in fall 2018, they are taking graduate seminar course, materials chemistry, general and inorganic perspective, and organic materials chemistry course. In the second semester, in coming spring semester, they will take theoretical and physical methods, analysis of materials, and laboratory research. In the fall semester, they will do one of the our elective offerings, as well as they will do one research course, and so on and so forth. In other words, that if there are students who are very well prepared, they can finish even in 3 semesters, but maximum it will take 4 semesters. With this information, I would like to turn over to my colleague, Dr. Yalan Xing, who will talk about faculty profile and the faculties who will teach you in this program.
Thanks, Professor Chauhan. Good afternoon, everyone. This is Professor Yalan Xing. I will be introducing our 6 full-time faculty members in this program. First, let's start with our department chair, Professor Bhanu Chauhan. Professor Chauhan did his postdoc from North Dakota University and PhD from Montpelier University. Professor Chauhan is our expert in materials chemistry. His research focuses on the creation of novel nanoscale materials and the study of their applications. The training in his group prepares students for work in either industry or academia by developing skill sets in catalysis, drug delivery, synthetic, and characterization techniques of hybrid nanoscale materials, small molecules, and polymers. Professor Chauhan is the editor and author for several books. The most recent one is The Novel Nanoscale Hybrid Materials from Wiley. He also published many peer-reviewed journal papers with student co-authors. Then I'd like to introduce our physical chemist, Professor J. Foley. Professor Foley obtained his postdoc training from Oregon National Laboratory Center for Nanoscale Materials. He did his PhD from the University of Chicago. Professor Foley and his research team are deeply interested in the study, design, and understanding of nanomaterials from the theoretical perspective. They pursue their research interest by seeking to discover and elucidate new phenomena that occur when light interacts with nanoscale materials. Professor Foley's research involved many students, and their results have been published on many prestigious peer-reviewed journals, such as Journal of Physical Chemistry C, ACS Photonics, and Nature Photonics. Next, I'd like to introduce our inorganic chemist, Professor Mihaela Giteanu. Professor Giteanu received her postdoc training from Rutgers University and PhD from University of Bucharest, Romania. Her research focuses on synthesis and characterization of various inorganic materials and their applications. The inorganic materials her research team has been working with include layered double hydroxides, titanium oxide composites, and rheology of hydrogels, melting gels, and so on. Professor Giteanu also published many research papers with student co-authors, including the most recent publication on the International Journal of Biological Micromolecules. Now, I'd like to introduce our bioorganic chemist, Professor Parminder Kaur. Professor Kaur did her postdoc training from UC Irvine and PhD from Texas Tech University. Professor Kaur is interested in the synthesis and study of biomaterials and supramolecular materials, such as metal organic frameworks. Professor Kaur is also interested in asymmetric catalysis using new catalysts and non-precious metals under milder and more environmentally friendly conditions. Professor Kaur and her students published many research papers on peer-reviewed journals, including Tetrahedron Letters and Chemistry Select. Next, I'd like to introduce our biochemist, Professor David Snyder. Professor Snyder received his postdoc training from Florida State University and PhD from Rutgers University. Professor Snyder's research focuses on how to use computational techniques to understand the structure and dynamics of the biological materials, proteins. Additionally, his research group is interested in developing bioinformatics-based approaches to predict protein flexibility. Professor Snyder and his students have developed several computational softwares and published research papers on peer-reviewed journals such as Proteins and Journal of Magnetic Resonance. Finally, I'd like to introduce myself. I am Professor Yalan Xing, and I am a synthetic organic chemist. I did my postdoc from Harvard University and PhD from West Virginia University. My research interest focuses on the development of novel synthetic methodologies to provide unique access to organic materials and small molecule agents, and ultimately address the increasing need in biomedical research. Our group published several research papers with student co-authors for the last few years in a journal such as European Journal of Organic Chemistry, Organic Letters, and Tetrahedral Letters. Now, I'd like to turn it over to my colleague, Professor J. Foley. He will be talking about our facilities and career choices.
Thank you very much, Dr. Xing. So this is Professor Jay Foley, and what I'm going to tell you about is our facilities. So now that you've heard a little bit about the people that will be mentoring you and working with you to conduct a program of research, I also want to tell you that we have the facilities necessary to actually support this conduction of modern materials research. And so what actually we mean by a program of modern materials research is actually an integrated approach for designing new materials that are going to address the problems facing humanity, to actually create those materials in the lab, and then to also characterize those materials to tell you what properties they're going to have and whether those properties meet the desired criteria. So in essence, you can think of three complementary areas for this instrumentation. One way of conducting this kind of integrated materials design and creation approach is to actually start by designing new materials for a given purpose on a computer using methodologies which are based in sound theoretical principles. So we actually have an incredible suite of computational and theoretical methods and computer resources to conduct these types of explorations on. Once you've designed this material, you can actually go into the laboratories where we have also a whole suite of incredible instrumentation to help you actually synthesize and isolate materials. And then for characterization, we have both imaging and analytical instrumentation that can allow you to look into the detailed structure of those materials, characterize them at a chemical level, and think about how those materials are going to actually address the desired purpose that you had in mind. So really, we're quite unique in being able to offer this this full capability within a department of our size with the level of engagement that we'll give you. And then I also want to say something that is not on this slide, but we have also developed several strategic partnerships with national laboratories to actually have access to facilities which can't be housed within a given university. And so a couple of examples of those would be things like synchrotron radiation sources that allow you to really do the types of imaging and materials characterization that just simply aren't possible in any kind of laboratory or benchtop setting. And we also have access to one of the world's fastest supercomputers through these strategic partnerships. So those are really unique capabilities. So so if you've come to our program and participated and worked in such a program of research, you might ask, well, what are the kinds of things that we can do? And so you might know that the materials industry is expected to see a lot of growth in the future. And one of the reasons why is that materials are really ubiquitous in our economy, and many of the pressing problems facing humanity are actually going to be, the solutions to those problems can be enabled by the design of the next generation of materials. And so you can think about industries like the technology industry, where the current state of things, where we have these computers that fit in our pocket, which we call the iPhones, that are orders of magnitude more powerful than these gigantic supercomputers that were that people, fit into giant, entire rooms back in the 70s. A lot of this advance was enabled just by understanding the materials properties of the semiconductors and being able to engineer those. So now we've actually, in that industry in particular, we're facing actual fundamental limits with the materials that in order to continue to keep up with this pace of progress, we're going to actually have to discover entirely new materials to build the information processing and storage components of our next generation of computers. And those materials might be quantum materials, they may be nanomaterials, they may have interesting optical properties, interesting magnetic properties, and you can study these kinds of things in our program. The pharmaceutical industry is another great example where many of the human health problems are going to rely on the creation of new pharmaceutical molecules or the repurposing of existing pharmaceutical molecules. So there's a broad area in biomaterials chemistry that is all about designing those new molecules, characterizing those molecules, creating catalysts for those new molecules. And even things like the textile and fiber industry. So there's an increasing interest in developing smart materials that are going to be able to do things like keep you cool or perform other functions within a household appliance. So you can start to think about engineering the next generation of materials through, particularly through the design of nanomaterials and integration into current materials. So there's many, many possibilities. What is required to actually enter this program? So we require essentially a bachelor's degree in chemistry or a related field. So a couple of examples of related fields might be material science and engineering if you have an undergraduate degree in that field, chemical engineering, physics, biochemistry, and others. So if you are wondering about if your background is relevant, just ask us. At least one semester in physics and mathematics is required, so we need you to come in with some solid background, which would normally be obtained in with a chemistry degree. Satisfactory score on the graduate records exam. If you are graduating with a BS or an ACS certified BS in chemistry with above a 3.0 GPA, the GRE requirements can be waived. We'll ask to see 2 letters of recommendation from people who can speak intelligently on your potential to succeed in a graduate program and in conducting research. And if you're coming from abroad, from a non-English speaking country, we'll need to see some satisfactory score on the test of English as a foreign language. And with that, I'm going to turn it over to my colleague, Dr. Parminder Kaur, who's going to tell you about some of our success stories.
Thank you, Dr. Foley. Hello, everyone. I'm Parminder Kaur, and I'm going to walk you through some of the success stories of our students and how the chemistry program have helped them landing the job and how it is helping them currently performing their jobs that they are currently doing. As mentioned by my colleagues, our department has a very well-designed research-oriented curriculum where all our students gets the opportunity to get one-on-one mentorship, hands-on experience, especially with top-notch instruments like NMR, HPLC, TEM, and many more. Students are very, very welcome to use all these instruments by themselves to get the hands-on experience. That is one of the skills that they will need when they are going for the workforce. Our students after graduation usually gets jobs within few months. They are hired by top pharmaceutical companies, petrochemical companies, and companies that make advanced and modern materials. Here I would like to start with our student Catherine Abate, who has currently working in Jolt Communication as the VP and who graduated in chemistry and English as a double major, and she is successfully applying the skills that she acquired during her time at WPU in her current job. She mentioned that how the opportunities that she got in the chemistry program, especially the presentations and the poster presentations that she has done at various symposiums, is currently helping her during her meetings with clients that are top companies in the field, such as Novartis, Janssen, and many others. Another student, Monica Baranik, mentioned and shared her experience with us that how working with Professor Mihala Gitianu gave her the opportunity to learn the importance of data analysis and gave her the ability to critically think and analyze the data sets that she collected during her research with Dr. Gitianu. Some of our students, for example, Sadia Chaudhry, graduated and she's currently pursuing her PhD at one of the top university, Purdue University, in polymer chemistry. During her time here in the chemistry program, Sadia worked in collaboration with Professor Chauhan and Professor Snyder, where she worked on the interdisciplinary field of nanotechnology and biochemistry. She was able to publish a peer review article on her work that she conducted under the mentorship of Professor Chauhan and Professor Snyder. Here I would like to emphasize the fact that in our program, most of our students before graduating were able to publish a peer review article. Having a peer review article on your resume not only give you the skill set, but it also make your resume stand out when you are applying for the job or for the next future endeavor in your career, and that make you stand out as a candidate. She not only got a good application for her grad school, but also learned the skill set that is needed to succeed in the field that is a research-intensive field such as chemistry. Another student, Ankita Shah, who is working currently at Mondelez International, mentioned how working with Dr. Chauhan's lab groomed her as a researcher and boosted her confidence for public speaking. Dr. Chauhan's guidance and mentorship helped her landing her current job, where she is using her skill set of the synthesis of platinum nanoparticles that she is doing in her current job. Our Master's in Material Chemistry program is one of the unique programs in the tri-state area, and our students, Dina Mustafa and Chelsea Sweet, who graduated in 2017 after working with Roche for a year, the job that they started immediately after their graduation, they are now enrolled as our Master's students, and they are about to complete their first semester. They were mentioning how our coursework, especially the course that they took, organic materials and inorganic materials, is helping them to understand their current job and how the modern materials behave in a particular reaction. So our coursework is much deeper and give our students a very deeper knowledge of these modern materials and how to handle them. Ms. Dina and Ms. Chelsea worked with that they are pursuing the master's program and about to finish their first semester. Next, I would like to talk about our student, Justin Domeno, who graduated in 2017. Our faculty, as a department, we encourage our students to interact with us so that they feel free and discuss their interest. Justin started as a biology major and changed to chemistry, and later on decided to work with Dr. Xing. And during her time with Dr. Xing, he published 2 papers in collaboration with Professor Xing and Professor Chauhan, and those published papers are in tetrahedral letters and molecules, which are benefiting Justin for his future career. So at this point, I would like to emphasize that our major goal is to achieving your dreams. So at this point, I would like to switch it to Brian to wrap up the webinar. Thank you for listening to us.
Thank you very much. For anyone who may have joined us late, I just wanted to remind you of a couple things before we formally wrap up and conclude our presentation. The first, I can't stress enough, we have our next graduate open house coming up on Sunday, February 10th. If you were interested in what you heard, if you're considering applying for the program for one of our upcoming terms, I can't stress enough, we'd love to have you join us for that open house. It's a good chance to meet faculty from our Department of Chemistry to talk further about your interests, about research opportunities, to get a feel for if the program might be the right fit for you. Again, that's going to be on Sunday, February 10th from 1 to 3 p.m. You'll be receiving an email from us, an invitation to that event in a couple weeks, so just keep your eyes out for that if you are interested. And more information will be up on our website at wpunj.edu as well. Also want to make sure you are aware we did record this presentation in its entirety. So if you joined us a little bit late and you missed the intro part of our presentation, or if you had to leave a bit early for one reason or another, we're going to be sending you an email with a link to our YouTube channel after the recording is posted, and that'll give you the chance to go back and take it all in again. If there are any of the slides that you want to refer back to, I know a lot of information was covered, and we want you to have that opportunity to do so at your convenience, whether it's on your couch, in your office, or otherwise. And lastly, I just wanted to thank you from the Office of Graduate Admissions sincerely. I know there are always other things you could be doing with your time between family, work obligations, school, and otherwise. We can't thank you enough for taking time out of your busy schedule this time of year to join us. On behalf of the Department of Chemistry, I want to thank you for looking into their program further. Certainly, it's our hope that if you haven't applied already, we'll see your application in the near future. But this formally concludes our presentation. We will be sticking around for a couple minutes. If any of you do have any questions questions, feel free to just type them in the chat box there. We'll stick around if anyone has any questions. But for all of us here in the Graduate Admissions Office and for our Department of Chemistry, thank you very much. Enjoy the rest of your week and enjoy the holiday season. Take care.